In this video I will look at sideband noise generated in 50 ohm resistors. The first one is a 51 ohm carbon composite resistor. I think it's rated 0.25 watts, but I'm not perfectly sure on that. I can also connect dummy loads on this B and C connector and then have nothing inside the box. But this resistor comes first. The output impedance here is no longer 50 ohms, it is 25 ohms because I have two 50 ohm sources in parallel. So I need to calibrate the noise floor of the low noise amplifier. The noise figure shouldn't change significantly for this modest impedance change. So what I do is to set maximum attenuation here, and then I get the noise floor, and this was calibrated to give 0 for 72 ohms, and now I have still 0. So far so good. We turn up the signal, but not to the full level, 10 dB attenuation, and I see a lot of noise. The power is minus 5.8 dBm. And the noise floor 1.6. I put 3.5 volts across the resistor to give it 1/4 of a watt DC power. And I don't see much of a difference. I can read from here to here. And the result is exactly the same. So DC current doesn't change the properties. I switch on 10 dB more signal, and you can see the noise goes up very much. I have set no attenuation, and then the signal level is 5.1 dBm. There is no resistor inside the box now, but I have put a SMA male dummy load in the B and C connector. And I will test different dummy loads without changing anything on the attenuator, so the power level will be the same for all these tests. And the noise level I see is 0.16. And I switch on 3.5 volts to give 1/4 of a watt to the dummy load of DC power. And I make a timestamp here by turning on the attenuator. And while running DC through, I see 0.17 dBm. I don't think this is significant. This is a female SMA 50 ohm load, and it has a manufacturer here. Now I can see it. Venchel 50 ohms, and there is a model number on it. And it's more noisy, 0.37 dB. And I add some DC power to it, like that, and make a timestamp for that. The new noise floor, I waited a little bit too long to see the timestamp anymore, but I see now 0.36. So the DC power through the resistor doesn't change the noise that it generates. This is a dummy load with an N connector on it. And the noise is, if I read it out here, I see 0.48 dB. This is another one of the same kind, and it's obviously not very good. If I read here, it is 24 dB noise floor increase. So something is wrong with this one. I will try to open it and look inside. The resistor should be soldered to this end plate, but it is broken, and I can see that the metallization is not present at the end of the ceramic substrate. Maybe better seen with the magnifying glass. So I can see that the end of the ceramic is visible. Repair was successful, at least almost. I see a high noise level with occasional bursts of noise. So if I read all of this out, I see 1.6 dB. And that's fairly high, but very reasonable compared to what I saw before. I have several of these dummies. I will check them all, but I will not demonstrate in detail what I do. I will put them in the table only. This one, number 4, is also broken. I tried to send some current through it, and that helps. So that repaired it temporarily, but something is wrong with it inside. It has the same problem, although this one I have tried to repair, not very successfully, sometime long ago. I have wound a thin wire on the damaged part, and then I can fill the whole region with tin to replace the damaged metallization. So this is what it looks like now. It's hard to get a good picture, I think. And the other end is perfectly in order, so I can solder that as intended. So here is the good end of the resistor, and now I can solder it to this don't remember what it's called in English, this disc of metal. Repair has been successful, and the noise floor I see is now 0.85. This one is labeled RF3402, and it's quite good. Noise is 0.41. This one is homemade. It has a metal film resistor inside, and it's good. 0.18. This one is homemade also. It has a carbon film resistor inside, and it's also good. I read 0.17 for this also. This one has a carbon composite resistor inside. It's very noisy. It says 5.2 dB for the noise floor. This one is from Mini Circuits, and it gives 0.15 dB. This is a 2-watt termination resistor from Tektronix. And it's 0.14 dB. This is probably a metal oxide resistor, what I know about it is rated 1 watt. This is the kind of resistor I have in the selective load of the test system. The noise from it is small. I see a 0.14 dB increment on the S-meter. Well, it's now clear to me that noise in resistors is not much of a problem. These are all the ones, and I look for dBc per hertz. The carbon composite is not perfect at all. The other ones are close to the limitations of the system. Not this one that I repaired, but these are probably carbon film and maybe I damaged by heating. I had to repair 2 of them, and one was not possible to repair. It was damaged out of repair. And here again is a carbon composite that I had mounted in the BNC connector. Otherwise, resistors are more or less perfect because they approach the limitations of my test system, so the noise from them is far below what you see here. And I haven't tried to correct for that. Then I have to worry more about precision in various details.